Okay. So let me give you a quick one on Mars one overview of the subject. So here is scale images, photos of the Earth and Mars. How does Mars compare in size to the Earth?
Smaller.
It's smaller. It is, in terms of other planets that are similar in terms of size and composition and so forth to the Earth, Venus is much more similar to the Earth than Mars is. But in terms of environmental conditions, Venus is a hellhole that no one thinks of sending people to, or that there's any chance that there's anything living there. So we've always had much more interest in Mars. Mars is smaller, not exactly the red planet. Okay. More the butterscotch planet, but anyway, here's just some overall comparisons. Again, the difference in size. Mars has about the same tilt of its axis as the Earth does. Okay. So in terms of the Earth, the axial tilt is about 23 degrees. For Mars, it's about 24 degrees. And what does the axial tilt control on the Earth? Why is it important that the axis of our planet is tipped over?
Controls the seasons.
Controls the seasons. We're in the middle of winter on the northern hemisphere now because the northern hemisphere is tipped away from the sun. And that has a variety of effects that we'll talk about when we get to climate. So what do you expect about climate on Mars? There will also be seasonality. Now, to what extent it will be similar is something we'll have to go into. But, this is actually not a trivial point. This is a very important way of understanding the worlds around us. We know something about the Earth. We know that because the Earth is tilted on its axis, as a result we have seasons. We take that information about the Earth and apply it to understand Mars. Mars has a similar tilt, therefore we would expect it to have seasons. This general approach is known as the use of analogy. You may be more familiar with the term of analogy in terms of literature and creative writing, but analogy also plays a role in scientific analysis. If we understand one system and how it works, and we see another system that has some similar features, we make the leap to initially assume that those similar features are going to cause similar behaviors in that other system. Something we have to test. We can't take analogies as given necessarily, but it provides us a way for beginning to frame our understanding about this new system. Okay, so the year on the Earth is 365 days. Mars is which planet in the solar system? Four, okay, fourth rock from the sun. Okay. As a result, and we'll talk about this a lot more when we talk about Kepler, it has a much longer orbit around the sun. So a year on Mars, well, before I talk about a year on Mars, a day on the Earth is 24 hours. A day on Mars is just slightly more than 24 hours. So if you were actually to go to Mars, you would have day-night cycles that would seem very familiar based on our experience here on the Earth. We would have seasonal changes over the course of the year that we could understand based on our experience here on the Earth. But those seasons would be roughly twice as long. Not quite twice as long, but close. Okay? So, if you're in the northern hemisphere, there would be a spring, a summer, a fall, and a winter. And those just would take longer to go through than comparable seasons on the Earth. Gravity is lower because it's a smaller planet. So you would weigh 1/3 as much on Mars as you do on the Earth. Your mass obviously would be the same, but because there's less gravitational pull, your observed weight would be lower. It's further away from the sun, therefore you might expect that there's less light. And there is an atmosphere on Mars, but instead of it being mostly nitrogen and oxygen, which is the case for the Earth, Instead of it being mostly nitrogen and oxygen, which is the case for the Earth, the atmosphere on Mars is mostly carbon dioxide, and it is substantially thinner atmosphere. It's less than 1% of the atmosphere of the Earth. But it's not nothing. Okay? I mean, technically, even the moon has an atmosphere that you'll encounter stray atoms floating around above the surface of the moon every now and then. But Mars actually does have enough of an atmosphere to matter. Okay, so on the one hand, in many ways, Mars is very much like the Earth. It's a little bit further out from the sun. Its day length is about the same. It's a little bit longer, and so we talk about sols on Mars rather than days. So one day on the Earth is 24 hours. One sol on Mars is a little bit longer. Longer year. Its orbit is not quite as circular as the Earth, but it's fairly close. As we talked about, its tilted axis is about the same. And its surface gravity is a bit lower, but it's not anything that would make you uncomfortable, right? I mean, if you walked around in 1/3 gravity, you would just have a spring in your step. It wouldn't be anything really tough to deal with. And in many ways, Mars is very different than the Earth. Okay, its mean temperature is much colder. And why would you expect that to be? Further away from the sun is a big part of it, but it's not the whole thing. And so we'll talk much more in detail about what are the factors that actually control the surface temperature of planets and how that has happened, what's happened on Mars compared to the Earth. And at that point, we'll throw in what's happened to Venus as well, because, you know, why has Venus become such a hellhole? As I already talked about, the atmospheric pressure is less than 1%. And so the air is much thinner, and it is toxic to us. I mean, there's basically very little available oxygen. It's mostly carbon dioxide. There is no global magnetic field. And as a result, there's no magnetic field to shield the surface of Mars from the solar wind. So the solar wind just comes pouring right down to the surface of Mars. Whereas we have a magnetic field that prevents all of those energetic particles from the sun from coming down to the surface of the Earth. The Earth is really a pretty nice place. Mars also no longer has plate tectonics. It's unclear whether it really ever did have substantial plate tectonics, whereas the Earth clearly does. So take a couple minutes right now on your sheet where you listed what you know about Mars, and answer the following two questions. In what way, let's assume that not magically, because this is a science class, I Star Trek teleported you all right here from the classroom to the surface of Mars. And you're on the surface of Mars, unprotected, well, with the clothing you've got on here. Mars is going to try to kill you in a variety of ways. What are all the ways that Mars would kill you if you were transported there? And what would kill you first? Okay, so who wants to volunteer some ways that Mars is out to kill us?
Radiation, lack of oxygen, cold temperature, lack of basic
So radiation, well, let me actually. Cold temps, we could freeze to death, we could be killed by the radiation. What else did you say? Lack of oxygen?
Lack of oxygen. I guess like no food or water.
No food. I'll put a question mark after water. I mean, there's clearly not any bubbling brook that we could drink water from. How else might Mars try to kill us?
Solar wind kill you?
The solar wind would be part of the high radiation levels. And in what way would the high radiation levels kill you? This is not nuclear reactor core breach kind of radiation levels. It's just higher radiation, higher UV. There's nothing to screen out there's no ozone layer to screen out the UV. So one issue that we have to deal with is the potential for increased cancer rates and other kinds of chronic diseases like that is driven by the radiation environment. You're not going to get acute toxic radiation poisoning and die in a week. Freezing to death, that could happen. Lack of oxygen, no food, no water. Previous classes have said the angry Martians could kill you. No one brought that up this year. Okay, which of these would likely kill you first?
I'm gonna go ahead and guess that the lack of oxygen for you.
Okay, so how long can you live without oxygen?
3 minutes.
Okay. How long will it take you to freeze to death at minus 63 degrees?
2 days.
Quickly, what is, I don't really know, what is that in Fahrenheit?
Minus 63 degrees Celsius would be like minus 70 degrees Fahrenheit.
Okay.
Okay. Minus 40 is the same on both scales. So anything below minus 40 is it's just cold. Okay. So you're not going to last long at that temperatures, but you probably will asphyxiate before. Well, there's lack of oxygen, but there's also low pressure. So is it the lack of oxygen that's going to kill you, or is the low pressure going to cause your eyeballs to blow out like in the... How many of you watched the original Total Recall movie with Arnold Schwarzenegger? Okay. Yeah. Not exactly realistic, but... And besides, if the heroes have experienced so much low pressure that their eyeballs are out of their sockets, all of a sudden having more air pressure, it's not going to reverse that. You're not going to. Anyway, yeah, probably asphyxiation would do it. So, if Mars is such a crappy place, why are we interested in it?
They had sustained life at one point. It's sustained life for us.
Why might we be interested in whether or not there was life in the past?
Because there could be like the possibility of more life in the future there.
When you were talking about life in the future, you're talking about us going there, or Mars life developing in the future?
I didn't say life in the future.
Oh, okay. So we might be interested in Mars because of questions about life.
Well, so if life was found on there, there's this thing called like a great filter, where if life is dead there, that would mean that like whatever happened in our, solar system, we survived it, we evolved from it, and if it happened again, then we...
Yeah, the great filter usually doesn't, well, the great filter is an idea to explain the Fermi paradox, and the idea is that if you get life developing in a place, and it evolves, and it becomes advanced life, and becomes technological life, then there's the potential for technological organisms to kill themselves off. I mean, that's a big concern on our plate right now. And so we might, if we start exploring the universe or the galaxy, find many places where there was advanced life in the past and they did something stupid and they killed themselves off and they did not survive the Great Filter. Life on Mars is probably never at that level. Okay. So if there was life in the past, it may have been bacterial order life. There may have been simple multicellular organisms, which would be really cool to find fossils of ancient Mars life. But it's pretty clear that Mars romanticism aside, there probably was never advanced civilizations on Mars. So the Great Filter idea itself would not necessarily apply to Mars, but it's an interesting concept.
There's also the fact that Mars is mostly composed of CO2, and we're wondering how it got to that level, and maybe we can prevent it from happening to the Earth.
Okay, so what you're talking about is essentially comparative planetology. If we can understand how Mars got to be the way it is today, then we can better understand how the Earth works and maybe take better care of the Earth, or at least modify, the projected pathway for the Earth. So that deals not only with Mars but with Venus, with Jupiter. All of these studies that look at other planets basically give us a good way of understanding what's going on the Earth. So that's clearly an important reason why people might be interested in studying Mars. Going back to life, the issue that we have studying life on the Earth is essentially we have one example of life. Because as far as we can tell, every organism that's on the planet today derives back from a common ancestry. Therefore, we have the same genetics, we have the same metabolism, basically, and so we're really kind of restricted in a more theoretical understanding of biology. We don't really know what's possible with life because we only have one example of life that we can study here on the Earth. If we found life on Mars, then either that's a totally separate, independent origin, and we would all of a sudden have a sample size of 2 rather than a sample size of 1, which would be just incredible for biology. It would allow us to say, what are the properties of life on Earth that are there because life has to work that way, versus what's just a weird thing that developed on the Earth, and life elsewhere might develop differently. The other alternative is that we find life on Mars and we find it's related to life on Earth. Now, how would that be? How could that be?
It's probably a common ancestor, like maybe within our solar system or our galaxy.
Yeah, but on Earth we usually talk about common ancestors, floating on the ocean currents or migrating from North America to South America. If we're talking about Earth and Mars, how would we get life back and forth between the two? Space aliens.
That gigantic, thing that hit Earth, that kind of
Right.
debris crash.
So Earth and Mars are exchanging material all the time. More so in the past. One of the researchers has explained it as, they're swapping spit back and forth all the time, basically. So, life could have started on Mars and got transferred to the Earth and developed on the Earth and died out on Mars. Life could have started on the Earth and transferred to Mars and died out. Life could have started separately on both planets, in which case we'd have an independent origins, a second genesis. Or life could have started on the Earth and never ever been on Mars. And any of those situations would be interesting. What about some more practical issues why people might be interested in Mars?
Could be a really good potential energy supply.
In terms of what? I mean, they're not gonna have hydrocarbons. There's not,
Like solar energy.
Okay.
Or lunar, if you can figure that out.
so, can we think of Mars as a source of resources for the Earth? It's probably not gonna be economically viable. You're probably not gonna be able to build a business case to go to Mars and find something that you bring back to the Earth unless it's really something spectacular. More along the lines is, though, not so much that the resources on Mars would support people here on Earth, but the resources on Mars would support people from Earth colonizing Mars, and now all of a sudden we have a whole second world to develop politically, economically, socially, scientifically, whatever. So a new outpost of, a new frontier, a new outpost of humanity potentially. Okay. So just some pretty pictures to end this all off. We have Earth that we're familiar with. The picture I picked up is, I point out there, is from the Sonoran Desert, I believe. Yeah, it's got saguaro cactus in it. So this is a fairly dry, arid place in the southern United States. How many people have been out to Arizona? Okay, Sonoran Desert. Lovely desert environment. But even as arid and stressful an environment as that is, it's nothing compared to Mars. So there's a picture of Mars. This is the Pathfinder landing site in Aries Valleys, I believe. Is just one of the main craters that the Opportunity rover explored in Meridiani Planum, Endurance Crater. And we really should kill all the lights for these, but I won't bother. Here's a view from one of the hills that the Spirit rover climbed. So in terms of landscapes and vistas, a lot of Mars kind of looks like the desert Southwest. If you're a geologist who is comfortable or who loves studying those kinds of landscapes, you would kill to get a chance to actually explore those on Mars. And here's just the Gale crater, which is the most recent spot that we've touched down with the Curiosity rover. Again, visually looks very much like a cold desert landscape, very familiar, and of interest. Let me take the time. Let's see, audio. I've got a bunch of clips that I've used in the past to talk about why we might be interested in Mars. I just want to pull up one of them, and we'll talk about that for a little bit, and then I want you to fill out some surveys so that I've got some information on you.
What will the challenge of the Martian frontier do for us? Well, we'll start feeling the value of that challenge in terms of invigorating our society even before we get.
Yeah, we're not going to get audio through the sound speaker apparently.